Let's talk about the law of cosines. The law of cosines is used when you do not have a complete set. So if you have a complete set, or you can use your 180 rule to find a complete set without too much trouble, use the law of sines. As a general rule, law of sines is way faster to solve than law of cosines. So if you have a complete set, use law of sines. It's faster. If you do not have a complete set, that's where you have to use law of cosines. So let's introduce what the law of cosines is. We have 3 different versions of the law of cosines. But instead of memorizing all 3 versions, I want you to notice the pattern, between the 3 versions. First thing I want you to notice, whatever letter you start with, here, let's color code these a little better. Whatever letter you start with, the other 2 sides come next. Kind of like Pythagorean's theorem, you'll notice. So if I start with a squared, then I do equal, and I have the other 2 sides squared and added, b squared and c squared. If I start with b squared, then I have a squared plus c squared. If I start with c squared, then I have a squared plus b squared. Whatever side you start with, the other 2 sides squared and added come next. Next up, we always have a minus 2. That is always there. That doesn't change no matter what. Then you repeat those 2 sides again, but multiplying to each other. So if I have BC here, then I have BC there. AC there, AC. AB, AB. Next, we always have cosine, because it is the law of cosines. And then finally, the angle that you end with is the angle paired with the side you started with. So this is A, so the angle is alpha, those opposite pairs. This is beta, it's paired with side B. This is gamma, so it gets paired with side C. So whatever you start with, essentially, you end with its angle pair. And that's the law of cosines. And that's how I want you to memorize it, using those patterns instead of just blunt memorizing the 3 different versions. Now, when we talk about solving using the law of cosines, we only have 2 cases that we solve for. The first case is side angle side, which is where we know 2 sides and the angle between those 2 sides. Now, there is a specific set of rules we should use when we're solving for this. And let me show you those rules in example 1. So here we have a triangle. Just like we did with law of sines, we're going to try to draw this triangle as accurately as possible. So we have about 50 degrees here for beta. Now we know that A equals 7 units and C equals 2 units. So let's make this side really long and this side pretty short. So we know this will be alpha because it's across from A. We know this will be gamma because it's across from C. And this will be side B because it's across from beta. So first off, notice that I have side, angle, side, 2 sides and the angle between them. And you'll notice it's impossible to find a complete set. I don't have 2 of the angles, so I can't use my 180 rule. And because I can't use my 180 rule, I don't have a complete set anywhere. So that's why I cannot use law of sines, because I don't have a complete set. So side angle side, we have to use law of cosines. So here's the easiest, fastest way to solve it. First, find the third side using the law of cosines. So I'm going to find side B first, using the law of cosines. Now, if I want to solve for side B squared, then follow the pattern. The next one, I have the other 2 sides squared and added. Then I always have minus 2. I repeat those two sides again. Then I always have cosine of the angle paired with the side I started with. So I started with side B, so that means I'm going to do angle beta, which is 50 degrees. So I'll just write, angle beta in there. So that's how we use that pattern. You use what you're solving for first, and then just use the pattern to finish it. So let's plug in what we know. I don't know B. I know A is 7. I know C is 2. Repeat those two numbers. Cosine of my angle. Now, you may notice pretty quickly, I actually almost have B solved for. The only thing left I've got to do is square root. So if I square root both sides, that will get B by itself. And then you can actually just type all that into your calculator in one smooth go. Just type it in exactly like I've written it. So if you type all of that in, you'll get that B is 5.916. So I now have all three sides solved for. But more importantly, I now have a complete pair. I have B and beta. So now that I have a complete pair, that means I can switch from using the law of cosines to the law of sines if I want. Read this note right here. You do not have to switch to the law of sines at this point. If you want to continue solving with the law of cosines, you're more than welcome to. Then you don't have to worry about the ambiguous case. However, law of sines will be faster to solve for at this point. So let's just get used to switching over to law of sines at this point because it is faster. And here's what we're going to do next. Now that we have a complete set, switch to the law of sines. But we're going to make sure to find the smaller angle first. Because remember, law of sines is going to find quadrant 1 and negative quadrant 4. So if we find the smaller angle, we don't have to worry about the ambiguous case. So basically, rule of thumb, solve for the third side using law of cosines. Switch to the law of sines, but make sure you find the smaller angle with the law of sines so you don't have to worry about the ambiguous case. So how do I know which angle is smaller? It'll be across from the smaller side. So C is the smaller side, so I'm going to solve for gamma. Solve for gamma because it's across from the smaller side. So let's use our complete pair and law of sines. So sine of 50 over 5.916 equals sine of gamma over C, which is 2. Now, you should be a pro at solving law of sines at this point. So what I would like you to do is pause the video, solve this out for gamma. You don't have to worry about the ambiguous case because gamma is an acute angle. You only have to worry about ambiguous case with obtuse angles. And since we're finding the smaller angle, you don't have to worry about it. So pause the video, solve that out on your own, and then come back to check your work. Let's check your work. I got 15.008 degrees for gamma. So there's my gamma. Now this triangle is basically solved for. All I need left is to find alpha. And since I know two of the angles, I can just use my 180 rule. So 180 minus 50 minus 15.008 gives me that alpha is 114.991 degrees. And now the triangle is completely solved for. So that is anytime you have side, angle, side. Solve for the third side using law of cosines. solve for the smaller angle using law of sines, because then you don't have to worry about the ambiguous case, then find the last angle. You'll notice that if I had tried to solve for alpha using the law of sines, my calculator would have given me the wrong answer, because my calculator would have given me the acute angle answer, not the obtuse. So that's why we always solve for the smaller angle with law of sines. Then we can use our 180 rule to find the obtuse one. So that is all we have for side angle side. In the next video, we'll talk about the last case with the law of cosines, which is side, side, side.